apologize for all the past couple problems were on part 1. The computer was really messing up, so I shut it down, saved the video, and now we're going to pick up at number 15, which is where we were. So, here we go. Let's take a look at number 15. The directions say to, let me get my book open here, find the perimeter of the region, okay? Now, guys, let's just stop and talk here and use some common sense, okay? First of all, it's common sense that if you're looking for the perimeter of this, that means you have to know the length of this right here. Let me slide this over real quick here. First of all, you have to know the length of this right here, okay? And you have to know the length of this. Well, that's obvious, 6 and 6. But then you have to know the length of this arc right here, or that semicircle, and then find the length of this semicircle right here. And then add all these numbers together. So, if you'll think about it, how would you find the length around this circle right here? Well, let me give you a little thought. If I had an entire circle like this, like that, no, it's not a very good circle, but if I had an entire circle like this, if I asked you to find the distance around it, you would find the what? The circumference, okay? And I really thought I had this problem fixed, and now the pen is totally messing up again, so we'll see what happens here. But anyways, so we have to find the circumference, okay? Well, we only want to find the circumference of half the circle, so we're still going to use the same formula. We're just going to divide it in 2. Let me show you what I mean, okay? So here we go. First of all, we know the circumference of this circle right here is pi d. So I'm going to use pi d. So where pi is, I put 3.14. And the diameter, again, if you draw your entire circle right here, you can see what the diameter is. It's 5, okay? So your diameter is 5. So if I multiply those two numbers together, that gives me the entire circumference around, I'm using my mouse, okay, so it's going to be a little sloppy, but 15.7 is the circumference around the entire circle. So divide that in 2, and you get 7.85. Now 7.85 is the distance around this much of the circle right here. But think about it. If this is 5 here, this is 5 here, that means this half of a circumference right here will be the same as down here. So I have 6 plus 7.85 plus 6 plus 7.85. And if you add all those up correctly, you will get 27.7. Alright? Okay, number 16. Alright, now, same thing, here we go. Look, guys, you want to find the perimeter around this object, correct? So, you have to find this length here, which is 12. Find this length here, which is 12. Now, if I were to draw a complete circle here, like this, and find the circumference all the way around the circle, that would be pretty simple to do. But I just want half of the circumference from here to here. And I just want half of the circumference down here, from here to here. Now if I draw my entire circle, the diameter is what? 7. And if I draw my entire circle up here, the diameter is what? 7. So we can find these circumferences really pretty easily, okay? So circumference equals pi d. Next, for pi I'll put 3.14, and for my diameter I'll put a 7, okay? So, there we go. Now, when you multiply 3.14 times 7, you get 21.98. Now, that's the circumference around this entire circle, okay? But I just want half of the circle right here. So I'm going to take 21.98 divided by 2 and get 10.99. Now, that means this length from here to here is 10.99. So this arc length from here to here is 10.99. This length is 12. So this length over here is 12 also. So if I take 12 plus 10.99 plus 12 plus 10.99, add all of those together, I will get 45.98, okay? Which is the circumference, or excuse me, the perimeter around this figure, alright? Alright. number 17. And we'll see if my pen will work here for a little bit. Now let's see what happens. Alright, here we go. Now, students, please notice carefully. I'm going to move this over here to the middle so it's have a little more space to draw on this thing. Now, listen guys. First of all, notice please, they want us to find the perimeter around this entire object. Now look, if from here to here is 5, that means from here to here is also 5. Do you see that okay? That means from, I want to change colors, now watch this carefully please. That means from here to here is 2.5, half of 5. And from here to here would be 2.5. Okay, so the radius of all these circles are, or the radius is 2.5. Okay, that's the radius of all these circles. Do you see that? Same here. If this is 5, then from here to here would be 5, which makes your radius 2.5. Same thing down here. Okay, so hope that makes sense to you guys. So I'm going to go ahead and draw that on there right now. Your radius right here is 2.5. That means the diameter of all of these circles, is 5. Okay, now I know from here to here is 5, and I know from here to here is 5, and I know from here to here is 5. Okay, that's fine. What I don't know is this arc length from green dot here to green dot here. So let's draw the circle off to the side. Let's figure this out. Here's the circle. It has a diameter of 5, and it has a central angle of 120 degrees. What is this arc length? Guys, we've studied how to do that. First of all, you find the entire circumference. How do you find the circumference of the circle all the way around? Pi d. So 3.14 times your diameter, which is 5. Alright. Let me grab my calculator real quick. 3.14 times 5 gives us 15.7. Now that's the entire circumference from here all the way around the entire circle. But we only want a part of that entire circumference. Just this part right here. Well, what part would that be? We'll take 120, the central angle, put it over the entire circle, which is 360. Reduce, and you get 1/3. So you really want to take the entire circumference, 15.7 times 1/3, and that will give you your arc length. Okay, so 15.7 times 1/3, 5.23. Repeating, or 5.2. So this arc right here is 5.2. So that means this arc here is 5.2. If this is 120 degrees, this is 120 degrees. The diameter is still 5, so this arc would be 5.2. And this angle here is 120 degrees, and the diameter is 5. That makes this arc here also 5.2. So we're going to have to add up all 6 of these parts. We start here. 5 plus 5.2 plus 5 plus 5.2 plus 5 plus 5.2. That'd be what? 5, 10, 15, 20, 25, 30. I'm getting 30.4 for the answer. 30.4. Let's see if that's correct here real quick. 30.71, close enough, because they're using their pi button and we're using 3.14. That's totally fine. Okay, number 18. Now again, students, same type of problem. Okay, same thing all over again. Did I work this one out already? I didn't think so. Okay, all right. Alright, here we go. Now, number 18. Now, we're going to find the perimeter around this figure. Okay, now watch. We know we're going to have a 6 right here and a 6 right here. Actually, that's incorrect. I apologize. 6 is referring to the entire height. This right here is 2. Okay, so I know I've got a 2 here, a 2 here, a 2 here, and a 2 here. Now, all that I have to do, students, if you'll watch this carefully, is just simply guys, think about it. Here's your entire circle right here. There's your entire circle, okay? Now, if the distance from here to here is 6, and from here to here is 2, this is going to be 2 here. They have to be congruent because all of these are the same semis, all the same little arcs right here, 90 degrees. 90 degrees, 90 degrees, 90 degrees. So this is a 2. This distance from here to here would be a 2 because of this 2 right here. And the distance from here to here would be 2. So what does that tell me? Well, it should tell us the radius of the circle, because if you took this line right here, and drew it straight to right here, then you have a radius of 2. In fact, all of these circles will have a radius of 2. Alright? So, what I'm going to do is this. This is so obvious, guys. If this arc is 90 degrees, that means it's 1/4 of the circle. 90 times 4 is 360. So this arc from here to here is 1/4 of the entire circle's circumference. 1/4 of the entire circumference. So I'm going to find the circumference pretty quickly here. Circumference equals pi d. Okay? So circumference equals 3.14 times. Now, if the radius is 2 right here, then the diameter all the way across has to be 4. So 3.14 times 4, 12.56, okay? That's the entire circumference, 12.56, entire circumference around this entire circle. But I only want 90 degrees of it, or 1/4 of it, and that's it. So take your, total circumference, 12.56. You can multiply it by 1/4, which is totally acceptable to do. Or you can just take 12.56 and divide it by 4, because we have 1/4 of a circle. 3, 1, 4. Alright? 3.14. Now, okay, students, back. Okay, so we know the distance from here to here is 3.14, because remember, if we do the entire circle here, the entire circumference would be 12.56. We just want 1/4 of that, so I take 12.56 divided by 4, I get 3.14. So the arc length from here to here is 3.14, the arc length. 3.14, the arc length from here to here is 3.14. The arc length from there to there is 3.14, and the arc length from here to here is 3.14. So here's what I do. I take 3.14 plus, now 6 is not the length of this line right here, okay? That's the whole distance from here to here. You only add 2, so 3.14 plus 2 plus 3.14 plus 2 plus 3.14 plus 2 plus 3.14 plus 2. And if you do all of that correctly, you will get the answer, which is 20.56 or 20.57. Okay, alright, moving on to numbers 19 through 22. Now these are pretty tough, so let's really pay attention and focus, okay? First of all, students, you have to understand something. Please don't miss this next comment. Every time you have a tire on a road, and here's the road, okay? Every time this tire rolls one complete revolution like that, okay, let's say this tire started to roll. Alright, let's see if I can simulate that. Probably not. It's not going to be very easy, I don't think, to do that. Pretty much impossible. Well, it would have to roll and move at the same time. But as this tire turns outside and you took a piece of chalk and put a little mark on your tire right there, and then rolled the car forward so that the tire turned one revolution. So this mark, this circle moved all the way to here. And when it stopped, this mark right here was back down at the bottom again like this. That's called one revolution. Now here's what I don't want you to miss. Please listen carefully. One revolution of a circle equals the distance traveled on the ground. So let's just pretend that the circumference of this circle, I'm just making this up, is, I don't know, 5 feet, okay? If that's the circumference of the circle from here all the way to here, when I take my hands and roll this circle, and I roll this circle, and it goes like this, and it rolls, and it lands right here, the distance that's been covered by its rolling is going to be the same as the circumference. So if the circumference is 5, that means this rock started right here and was done. When it's done doing one revolution right here, the distance covered will also be 5. So if the circumference is 5, then the distance traveled is 5. You need to understand that, okay? So what they're asking us to do, if you read the directions, is they're asking us to determine the distance the vehicle would travel in one revolution. So I just told you how to do that. And then determine how many times the tire would rotate in 1 mile, okay? So here we go. Here's my circle right here. Diameter's 12 inches. Let's find the circumference very quickly. The circumference would be pi d, so 3.14 times 12. Let me grab my calculator real quick. 3.14. 37.68 inches. So the circumference equals 37.68 inches. Got it? So that means when this tire has made one complete revolution, the distance on the ground that it's traveled is 37.68 inches. Okay, so there's the answer to the first question. Alright, now, next, how many times does this tire have to turn to make it go a mile? Now let's just stop and think about this for a second, guys. We know 1 mile equals 5,280 feet, okay? Now let's take 5,280 feet. Multiply that by 12, and I'll show you why I'm doing that in a second. And you get 63,360 inches. So if you have 5,280 feet, each foot is 12 inches. So take these feet and multiply it by 12, and you get this many inches. So 1 mile equals 5,280 feet, but 1 mile also equals 63,360 inches. So if the circumference right here is 37.68, think about that inches, then how many times would this tire have to go around and around and around until it's covered 1 mile? Remember, every time this tire makes one revolution, it's covered 37.68 inches. Well, guys, it's obvious. Let's see how many times 37.68 inches will go into, because there's this many miles right here in a mile. Let's see how many times 37.68 will go into 63,360, okay? And that will tell us then how many turns have to be made before the tire, so the tire will travel 1 mile, alright? So let's see, if we take 63,360 divided by 37.68, we're going to get 1,681. So that's not inches, that's turns or revolutions. So the tire's going to have to turn 1,681 times, or it's going to have 1,681 revolutions in order for the tire to travel 1 mile. Okay, let's try 3 more of these. They're really good. Let's practice these, alright? Alright, we have a bicycle that has a diameter of 26. We're going to do the 26 inches. We're going to do the exact same thing, okay? So here we go. First of all, we're going to find the circumference of the entire circle, which is pi 3.14 times the diameter, 26, okay? So 3.14 times 26, 81.64. and that would be inches because your diameter is in inches. So there's the total circumference. So listen to me carefully, students. When this circle here, this tire, makes one complete revolution, it will have covered 81.64 inches, okay? Now that's the answer to the first part of the problem. Now, how many turns do we have to take before it'll cover 1 mile? Remember, 1 mile equals 63,360 inches, okay? So, here's what we're going to have to do. How many times does 81.64 go into this number right here? Well, if you take 63,360 and divide it by 81.64, you're going to get about approximately 776 turns or revolutions. There we go. So here's the first answer. How far would the car travel after one rotation? And then how many revolutions would the tire have to turn to reach 1 mile? 776 revolutions, okay? Alright, exact same thing. Get a number 21, same thing. I have a motorcycle tire, has a diameter of 20 inches, so here it is. Diameter going straight across, 20 inches. Let's find the circumference of this tire. Pi d, so 3.14 times 20, alright? Don't know how that happened. Let's see, hold on 1 second. Yeah, 3.14 times 20. That would give us 62.8, alright? So the circumference is 62.8. That's the circumference. There's one answer to the first part of this problem. How, what is the distance on the ground this tire travels when it turns one revolution? Like I told you at the very beginning of the video, the circumference of a circle is the same thing as one revolution on the ground. So when this car has traveled one revolution, it will have traveled 62.8 inches. Now, like I've taught you, 1 mile equals 63,360. Alright? Now, that's how many inches are in a mile. Well, every 62.8 inches is one revolution. So let's see how many times 62.8 will go into 63,360. Alright? So if we type this in correctly, we will come up with 1,000 approximately. These are all approximations, but approximately 1,008 turns is how many turns this tire would have to make before it reached a mile. Okay? Alright. Let's continue on. Alright, number 22 should be the last one. Let's see how we do. Not the last one, the homework assignment, but the last one. And these 4 problems. Okay, here's your tire. Diameter of 36 inches. Alright. So, I want to find out how much distance this tire moves on the ground, or how much distance on the ground is covered in one revolution. Well, remember, one revolution is equal to the circumference. So circumference equals pi d. Pi is 3.14. Diameter is 36. So 3.14 times 36 would give you 113.04. 113.04 inches. So that's how much distance is traveled on the ground when a tire makes one revolution, okay? 113.04 inches. Now the back of the book has 113.10. But remember, they're using their pi button. They're not using 3.14. If you're using your pi button, I have no problem with that. If your answers are off a little bit on a test or a quiz, that's totally fine. Now, this is how far the tire travels, how much distance is traveled on the ground when the tire turns one revolution. But now I want to know how many times does this tire have to travel? Or how many times does this tire have to turn over and over and over until it reaches a mile? Well, remember, 1 mile equals 63,360 inches, okay? So that's how much distance this tire has to travel. So I'm going to see, remember this equals 1 revolution right here. 113.04 equals 1 revolution. So I'm going to see how many times this will go into this. And if you take 63,360 divided by 113.04, you will get approximately 560 revolutions. So that's how many times the tire has to turn in order to cover 1 mile. Okay, these are really good thinking problems. Alright, moving on to 31 through 34. Now, find the distance traveled by the tip of a 7-inch minute hand on a clock. Now, this is really not difficult. This is pretty simple. Here's your clock, students, and here's your 7-inch hand right here. When they're asking you how far does the tip of this hand travel, it's basically saying find the arc length. Think about it. If the hand started here and traveled to right here, the distance it traveled is from here to here, correct? That's nothing more than a what? Arc. That's all they're dealing with, guys. These are really not difficult problems. So let's take a look at the first problem here. I don't care about the hour hand. They're only talking about the minute hand. So the minute hand started at 4 o'clock. Now at 4 o'clock, that means the minute hand will be pointing to the 12. Okay, at 4 o'clock. Now at 4:20, the hour hand will be pointing to 1, 2, 3, the 4 right here. Okay, so now the minute hand moved from, let me change colors here. The minute hand moved from this dot here, and it traveled down to this dot here, and they want to know what distance did it travel. Now, students, think about this. It also tells us the minute hand is 7 inches, which means the entire diameter all the way across would be 14 inches. So we know the diameter of this circle. Could we not quickly find the circumference all the way around the circle? Sure we could. Circumference equals pi d, so 3.14 times 14. Let me grab my calculator real quick. Now we're going to use this same diameter for the next 3 problems, because for the next 3 problems, we still have a circle, a clock, with a 7-inch radius or a 7-inch minute hand, so the circumference is not going to change. So we get 43.96 inches. Now that's the total circumference, okay? Let me copy that real quick here so we have that. Now, this is the total circumference, so I've got to find this part of the circumference. You're like, Mr. Arrow, we've always had an angle before here, like 110 degrees, and we could take 110 degrees and put it over 360. I know you're used to that, but they didn't give us an angle, so think of another way that you can find what fraction of the circle this is. Guys, think minutes. The minute hand, when it traveled from here to here, traveled how many minutes? 20 minutes. From 4:00 to 4:20, it traveled 20 minutes. How many minutes are in a circle? Or how many minutes are in an hour? 60. So if this minute hand right here were to travel all the way back to here, it'd be 60 minutes. But this minute hand only traveled 20 minutes. So it traveled 20 out of 60. Reduce that and you get 1/3. So this arc length from here to here is 1/3 of the entire circumference. So take the circumference, 43.96, and multiply it by 1/3, or take 43.16 and divide it by 3. Either way, you'll get the same answer. It doesn't matter, okay? Let me grab my calculator. 43.96 times 1/3 gives us 14.65333. So 14.65 is good enough. So this arc length right here is 14.65 inches. Let's try another. Let's practice, okay? Alright, we have the same clock, okay? Same clock, same hour hand. It's starting at 12 o'clock. So here's your minute hand. I said hour hand, your minute hand. It's right there at 0, 12 o'clock, 12. Then it's going to rotate all the way around 59 minutes. So it'll be right here. Okay? So they want us to find the arc length from this point here all the way around the entire circle to this right here. Okay? Now, we already know the circumference of the entire circle. We do. Sure we do. Remember, this radius is still 7, so the diameter is still 14, so the circumference hasn't changed, okay? There's your entire circumference right there. That's not going to change. Now, what fraction of the circumference is this big old arc from here all the way to here? Well, how many minutes did it travel from here to here? 59. From 12 o'clock to 12:59. 59 minutes out of how many minutes? 60. So if you take your total circumference and multiply it by 59 over 60, let me grab my calculator real quick. You're going to get 43.23, and that is the length of this arc. 43.23. From here, where my pin is, all the way around the circle to right here. That's 59/60th of the entire circumference. Multiply that times the entire circumference, and you will get 43.23, the correct answer. Let's try another one, okay? Now we've got a circle or clock, and the minute hand is pointing to the 3 because it's 6:15. Then it travels down, and it stops right here at 6:27. Up here at 6:15. Okay, so the minute hand traveled from here down to here, which was how many minutes? Well, from 15 to 27 is 12 minutes. 12 out of how many? How many total minutes do you have in 1 hour? 60. So 12 out of 60 equals 1/5. So this arc right here, this arc length we're trying to find, is 1/5 of the entire circumference. Well, we already know the circumference is 43.96. So you take 43.96, you can multiply it by 1/5. That's totally fine. Or you can take 43.96 and divide it by 5. Either way, you'll get the same answer, okay? So let's see what we got here. 43.96 times 1/5 gives you 8.79 or 8.8. So the arc length from here to here is 8.8 inches, I believe. Yes, inches. Alright, one more and we're finished. See how you do, okay? Alright, so now the minute hand is going to travel from 235, that's the 7, all the way around to here, which would be about on the 5, okay, because it says 3:25, and so 25 minutes, the same would be on the 5. So this minute hand started here on the 7, and it rotated all the way around to the 5, okay? Well, now think about what fraction that would be, guys. From 235 to 325, that's 50 minutes. Do the math on it, okay? That's 50 minutes. So the hand moved 50 minutes worth of movement, and that goes over 60, which is your total circle if you started here at 7 and went all the way around to the 7 again. It'd be 360, or it'd be 60 minutes, excuse me. So I'm going to take 50 minutes over 60 minutes, cross that off, and this arc right here is 5/6 of the entire circumference all the way around. Alright, now we already know what the total circumference is, because the diameter hasn't changed. It's still 14. So here is the entire 36.96, and we can do one of two things. Actually, we're going to do one thing. We're going to take this and we're going to multiply it by 5/6, okay? Because this arc length right here is 5/6. No, that's incorrect, and I apologize, guys. It's this arc length from here. This is where the hand started. It's the arc length here, all the way around the circle to here. Very sorry about that. I'm obviously not going to redo an entire video because I messed up on the last problem, but the hand started here and went this way. So this big green arc is 5/6 of the entire circumference, and the entire circumference is 43.96. So if we take 43.96 and we multiply that by 5/6, we're going to get 36.63. So that is the length of the arc, 36.63 inches. Alright, so there we go. That's how you do these. I hope this homework video has been a help to you guys. If you have any questions, don't hesitate to call or email.